I'm Svetlana. I'm from Sydney. That's why I have such a Russian accent. I'm going to talk about property-based testing, and I feel like we talk a lot about this topic. Pretty much every functional conference is covering that. And why do we still talking about that? So how many people actually use day-to-day Scala check or some kind of like QuickCheck? Not that many, but and people who are aware of that? Yeah, like significant amount of that. So what is it? What is the barrier? Why can't we adopt it in our day-to-day job? So I want to start with a little live coding demo on how cool property-based testing is. And I thought maybe I should do like a live coding right now, but like, what am I, in a circus? I recorded that. I recorded that. So this is my very simple example of struggling with property-based testing with Scala check. And I picked up a very simple example of verifying a property of square root of multiplication of x is the same as x, right? So I just started testing that, and let me turn it on. Right, so this is my property. Yeah, square root of multiplication is the same as x. When I run the test, it fails. It fails because on a negative input, that's what Scala check tells me. Well, silly me, it's because obviously it has to be equal to absolute value of x, not just x, right? I run the test and it's failing again on this 50,000 something integer. And I'm like, what the hell is going on? And apparently there is this thing like integer overflow. When you multiply integers, you not necessarily get integers back. I'm like, okay, fine. I guess I can fix that as well. So what's the maximum value which is allowed? So it's about that. Okay. So the way I can fix it with Scala check, I can provide a classificator. I think it's like a precondition on your after-generated value. I can say, okay, give me any integer, but please make sure it's between this range. I'm really slow typer. And then I can run this property again. Do you think it's going to work? Why not? Yay, it worked, okay? That's not it. Now I want to see actually what happened, what kind of integers, what kind of values I just provided, right? So I can use this function collect, which can provide me a distribution of my values. So if I use this function and say, hey, run the test again, it says, oh, actually your distribution is that. So the only values which I tested on was 1, 0, and -1. Like seriously, any value and it's just -1, 0, and 1. So it's not something I'm happy about. Ideally, what I want is this distribution. The distribution I run on the x value before I apply this condition. Well, it keeps, turning it off. So instead, what I can do is I can actually limit the generator. Instead of using a standard generator of a, give me x, which is any kind of integer, and then apply condition, I can just provide my own generator and say, give me a limited number of integers. And then for this generator, for any value of that, I want to assert my property. And the distribution of that will be way better. This is something I learned. This is something I came across by just doing a very simple example, and this is something to be aware of in property-based testing. Even though you kind of saying, oh, I want to run this property against like all the possible data, you still need to verify what kind of data you're working with. Do not trust the generators, especially if you're trying to modify them. So you can see now I have a way better distribution of my values for my very important test, which I know it's not really important. It's all right. But it actually provides a very good insight on what property-based testing is, and it's a very powerful tool. Let me get back to that. So if we're talking about this tool, the Scala check itself, and I'm going to talk about Scala check, but at the same time, I think you can find these important parts in any other property-based testing framework. And I think there are at least 4 really important things you need to think about when you're working with property-based testing. So first of all, it's generators and arbitraries. So generators are things with generative values, and arbitraries allows you to summon these generators in your code. So the generator in Scala check actually gives you so many functions already which you can use to generate the values. You can use the string, you can use the random numbers, and it's really powerful. Even though sometimes it's not enough, it's already providing you quite a capability. So you can just create simple generators for your case classes like customers and stuff like that, and then use that in your tests. You can even limit the generators. You can have like a very generic generator and then limit it by, okay, give me the value for this generator and make sure that one of the fields is this, right? You can limit it like that. There are all sorts of ways of creating generators and then limiting them. Also, generators are monads, and we all like monads, right? No? Well, why am I saying that? It's because you can easily compose generators. So another thing is Scala check shapeless. It's also a library which helps you with generation of the values. What it does, it's actually cool. You can just provide case classes or seal traits and then summon the generators for these instances, and they're just going to be there. You don't need to create it yourself. It actually saves a lot of boilerplate code. Right. So that was the first part of the property-based framework. Generators and arbitraries. The second one is properties. And we're going to talk a bit more about properties because I feel like this is the most difficult part of adopting this approach is thinking about properties. But another part of the framework is actually properties, which is your just assertion statements, what to assert on. The third part is shrinking. Anyone knows what shrinking is? So remember in my example when I ran square root for the first time, the value I failed on was minus million something something. But the example they gave me was -1. So what happened is Scala check will fail on one of the examples, and then it will try to find the minimum value. This test still fails. Make sense? Cool. And the last one, I think it's really probably the most important one, is data distribution. Remember at the end, when my tests were green, I just wanted to check what kind of values I was generating. And I realized it was just 3 values for like 100 tests. Data distribution with Scala check is not what you think it is. I did like a very small course in university 10 years ago on statistics and something data. And I have some sort of like expectations when people talk about generating values. I expect like this amount of data will be normal, and this like small amount of data on the corners will be like edge cases. So with Scala check, it's not like that. With Scala check, majority of the values will be edge cases. Because it's designed like that. It's designed to provide you values of like -1, zeros, really big numbers, really big collections, really small collections, and things like that. So if you hear someone saying, it would be a good example if we seed our database with Scala check, it's a horrible idea because it's not going to be realistic data at all. If you want to seed your database with some sort of test data, you probably want to, I don't know, maybe do a snapshot from production and like mask this data somehow so it is actually realistic data. In other words, what I'm trying to say is please do not use Scala check for data generation. Right. But the thing is, what I'm actually trying to say is how do how do you use QuickCheck in your day-to-day job? And I don't know what do you do at your job, but I can actually tell you what do I do at my job. If you can relate to that, it's great. If you can't, I mean, like, maybe I'm in the wrong place. So at my job, every day I write functions which accept input, and they provide output. They talk to other functions, and they're pure. No, I'm just joking. So some of these functions actually send data to some other services, save to the databases, or talk to other APIs. Also, these functions need to be available over like UI or some other services, and I need to provide an API for these functions. So yeah, that's my job, and they still pay me. So at the end of the day, maybe I need to build some sort of API, like a typical REST API with HTTP GET, POST, PUT, delete. Right? So how do I do that? I have a module. Kind of like a routing thing, which accepts requests, sends it back to logic and rules thing. People call it service layer or something, I don't know. And this logic and rules thing somehow saves it to database or sends it to somewhere else and things like that. On top of that, I also have parsing. I have some validation rules. Make sense? So this is the app we're trying to build, right? So what are the expectations for the code? Like what would be the first thing you expect from it? I'm not asking how do you test it. I'm just asking, okay, what are the expectations? So my first expectation would be when I post a valid user request, the user should be created. Is it okay? Let me go through which layers it's going to touch, right? So I have a client which creates a valid user request. I route it back to the logic, and I save it to database, and I get back a response, right? So I know this test case touches pretty much every layer of my application. That's why I call it happy pass end-to-end test. But this is the first thing I think about when I build an application. And most of the people do. They just set up an expectation, okay, what am I building, right? So how would you test that? Excuse me for my Scala, I don't actually write Scala full-time. I don't even know people who write in one language full-time. Do people still do that? So my new favorite language is Ruby. This is example-based test. With example-based test, I'm very concrete about, okay, this is my customer. I want to create an HTTP request for that. And with my web server and a storage setup, like it's a full-blown end-to-end test, I post to the server, I wait till it's successful, and then I go to the storage and try to find this customer, and I set up an expectation that I can still find this customer in the database. Good test? Doesn't matter, it's all right. So with property-based testing, you can think about the same scenario, but with the properties, right? So you can say, okay, for any kind of customer, let's create a valid customer request and post it to the server. And then try to find this customer in the database and assert on the same thing. As you can see, it's quite similar test, pretty much the same. But in this case, we're getting any random values for the customer. Make sense? Cool. So if you think about the second expectations for this code, it's still a web server, right? It's an API, and we want to have a valid responses coming in from this API. So when I post a valid user request, I want to get either 201 or 409 if it's somehow already exists, right? So for this test, we're going to only cover the routing and the creation of the request, right? So in other words, this is just a unit test. I don't really care what that is, right? I can still write example-based tests for that, and they're perfect for that. I can create an instance of the customer, I can send it to the server, and I expect the response code to be created. Or same test, and I expect response code to be conflict. Right? With the example-based test, you kind of have to have two different tests for that. For the property-based test, I need to think about the properties. What is the property of my API? And the first thing I can think about is, well, anytime I submit a valid customer request, I don't really care what's happening inside. What I know for a fact that I can expect either created or the conflict response. And these are my two valid options. And if something is not that, well, something is wrong, right? Makes sense? Something I want to point out is these two tests are very different. They're testing different things as well. And we'll come back to that. But the main point here is property-based tests not necessarily always replace your testing strategies. So what are the other expectations? So that expectation is very simple, actually. It's my favorite simple example of property-based tests. Let's say if you have a request and it has all the valid expected information, this request should be valid, right? And I'm just talking about this thin layer of validation of the request, parsing and encoding, decoding, right? So for that, we can use this kind of property test. I think I call it round trip. When you create a customer as an object, convert it to JSON and get it back, and you expect the original customer. This is the simplest test, and in many cases, maybe it's not as valuable as you think it is, but if you have your own really weird way of decoding and encoding JSON, maybe it makes sense. Cool. So what are the other expectations for the code? The other one is when I save a valid user into the database, the entity should be created. Right? So what I'm talking about here is this little layer. When you have a logic and rules, and you accept a valid request from your routing, you just save it to the database. So I think it's kind of like covering unit integration tests. And if you think about property for this kind of test, what you can do is you can create a customer with a save method, and then get the saved customer with some other method which retrieves this entity back, or which retrieves this side effect which you created on the database back. I mean like effect, just it's not a side effect. And then you assert on that. So this is also round trip, but it covers multiple layers as well. What are the other expectations? The other expectations can cover some if-else conditions you may have in your rules and validation logic. Let's say if you want to post an evil customer, it should still be created, but at the same time, it should cause notification to be sent somewhere, right? So I'm still talking about this, this layer. This layer still covers unit integration tests. And what you can do is, all right, you have a customer service, which probably depends on some sort of queue which needs to receive these notifications. And when you save an evil customer, you can expect that this queue has something. Cool. Any questions so far? No? All right. So this is all I wanted to show you in terms of the example, right? And I just want to talk a little bit about different patterns we used when we think about the properties. I know it's not that easy, and it's really hard to actually like come up with the properties when you work with just simple code, which is not like some standard library for Haskell. So I found this article and I put it at the end of the presentation. Found this article which describes a few really useful patterns we can use every day. One of them is different path, same destination. It's a commutativity law. For example, if you have collection, you sort it and you map it. It's kind of the same as if you have collection, you map it and then you sort it. All right. Then round tripping. We actually saw that with the database example. We saw it with the encoding decoding. It's a very popular one. The more things change, the more things stay the same. It's more like idempotency principle. When you post and post and post, the user should be created, right? Still be there. Just one. Then another one is solve a smaller problem first, which is just an induction. Then hard to prove, easy to verify. What it means is the setup could be very complicated, and there must be like lots of things going on in the background. But at the end of the day, the user is just created in a database, right? It's easy to verify. And the last one is strategies. Strategies or multiple implementations. Let's say if you have multiple implementations of the same thing, you can just compare them together. Make sense? Something to be aware of with Scala check, and I don't want to go into very much details because I actually want to encourage people to use it a little bit more. But what we've seen already is that Scala check is just not enough. You need to have example-based tests in many cases as well. Not to mention, you need to have support for arbitraries because it's a nightmare sometimes to create your own generators just for simple things. So you need to have dates arbitraries, and you can also leverage shapeless as well. Some matches are not really available in Scala check, so you need to complement it with some other libraries. Data distribution is kind of weird. You need to actually verify what are you generating. Right, and I think I'm going to wrap up. Thanks a lot. And these are the references and credits to all the people who helped. Thanks a lot.
Thanks for the talk, great talk. Just one thing that I've noticed is these property-based testing libraries are all coming from functional programming side of programming. Is there anything inherent in functional programming that makes property-based testing easier, or is it just a historic thing that it started with QuickCheck in Haskell and it's been picked up from there on?
Yeah, definitely. I think it's a historical reason, but also functional programming does make it easier because of pure functions and immutability. But at the same time, pure functions and immutability are now available everywhere. And I am aware of at least few libraries in the common languages like C#, Java, JavaScript, Ruby, which support property-based testing.
So I've been doing some pretty involved stuff with Scala check, with defining generators, shrinkers, and all of that. And with some of this it becomes a pain. So are there any other libraries you've looked at in Scala for property-based checking, or is Scala check the best option? Yeah.
I know there is a Hedgehog alternative, like a copycat of the Hedgehog in Haskell. I haven't looked at that. Maybe it's less painful. I'm not sure.
Right. Please thank Svetlana.